Hey everyone, welcome to Chapter 5. Today we're going to start looking at Chapter 5 with Lesson 5.1. So please make sure you use graph paper for your notes for today's video. So take a moment to pause the video, get a piece of graph paper, and set up your note sheet with the section number, the date, and the I can statement. I can solve systems of linear equations by graphing. And then resume the video as soon as you're ready. All right, so before we dive into 5.1, I just want to mention real quick what we're learning in Chapter 5 so you have a sense of where we're headed. You don't need to write this down unless you want to. But in Chapter 5, big picture, our goal is to learn how to solve systems of equations. And systems of equations basically means more than one equation at the same time. Everything we've looked at so far this year has just been one equation at a time. But this chapter is going to be all about looking at multiple equations and how they interact with each other. And we're going to start with graphing, and then we'll move into a number of different algebraic techniques, go back to graphing just a little bit, and then finish up the chapter by looking at inequalities as well. So we're going to start today. Let's look at some graphing. And a lot of our problems will look kind of like this. So solve the system of linear equations by graphing. We want to graph each line and then find where the two lines intersect, because that will give us the solution to both of our equations. Both equations will be true only at the point where the two lines intersect. So if we look at this first one, we have y equals negative 2x plus 5, which tells us that we have a y-intercept of 5 and a slope of negative 2 because we're in y equals mx plus b form. So I'm going to go first put our y-intercept of 5, so 1, 2, 3, 4, 5. And then we'll use our slope, and our slope is negative 2, which means rise over run. So we go down 2 over 1. And for this, you're going to want to plot a number of points. And it's very, very important that you draw extremely straight lines for these problems, because otherwise you will definitely not find the right point of intersection. So I would strongly recommend that you use a ruler for your homework to make sure that you end up with the correct intersection. Hopefully your lines will be much straighter than what I'm able to do on this screen. So then y equals 4x minus 1, we have a y-intercept of negative 1 and a slope of 4. So we're going to start at negative 1. We're going to go up 4 over 1 and down 4 over 1. So 1, 2, 3, 4 over 1. 1, 2, 3, 4 over 1. 2, 3, 4 over 1. And again, we're going to draw on our line as hopefully your line will be much better than mine, as straight as possible using a ruler. So we can see here that we have an intersection point right here at 1, comma 3. So that tells us that 1, comma 3 is the solution to this system of equations. Now we want to check that to make sure that we're actually right. So if we plug 1, comma 3 back into each equation, so I'll start with the first one. So 3, because we're going to replace y with 3, 3 equals negative 2 times 1 plus 5. Negative 2 times 1 is negative 2, plus 5 is 3. So we have 3 equals 3. That's a good sign. We have to check both, though, so we're going to check the other one as well. So 3 equals 4 times 1 minus 1. 4 times 1 is 4, minus 1 is 3. 3 equals 3. Boom. So we've checked our solution to our problem by checking both equations with that point that we suspected was the solution to that system of equations. And it's really important that you always check both, because it's pretty easy to make a mistake and have it work for one but not the other. So another thing that you might look at with these types of systems is telling whether the ordered pair is actually a solution to a system of equations. In other words, you're given an ordered pair, like 1 comma negative 2, and you just want to know if it actually works for this system. And if we so let's plug this in. So x is 1, y is negative 2. So we have 2 times 1 plus negative 2. 2 times 1 is 2, plus negative 2 is in fact 0. So that works. Negative x, so negative 1 plus 2 times negative 2. Well, that equals negative 1 plus negative 4, which is negative 5. However, negative 5 is not 5. So in this case, the ordered pair 1 comma negative 2 works for one equation, but not the other. And if you think about it, what that means on a graph is that the ordered pair 1 comma negative 2 is on one of the lines, but not both of them. It's not their intersection point. It's just a point on the first line only. So we can look at another example here. X is 1, y is 4. So we would have 4 equals 3 times 1 plus 1. And 4 equals negative 1 plus 5. 3 times 1 is 3 plus 1 is 4. So that equals 4. That's a good sign. Negative 1 plus 5 is also 4. So that one works as well. So in this case, the first one does not have an ordered pair that works for both. The second one does. That second ordered pair 1 comma 4 is the intersection point for those two lines. So if we want to think about like overarching summary of what we're working on today, basically we have 3 steps in order to graph a system of linear equations and solve it. Step 1 is simply to graph each equation in the same coordinate plane, just like we just did. And I strongly recommend that you use 2 different colors, or a pencil and a colored pencil, so that you can easily tell your work apart. Step 2 is we want to know the point of intersection. And usually you can see that visually from the lines that you graphed, particularly if you used a ruler and graphed straight lines. And then step 3 is we're going to check the point from step 2 by plugging it into each of the equations in the original system. And it's really, really important that you do it in each equation. Please don't be lazy on this and just check it in one equation, because it's entirely possible to work in one and not in the other, as we just saw in the last example. So take a moment to pause the video and write out these 3 steps, and then resume the video whenever you're ready. All right, so our next example is very similar to the last one. And if you're interested, you might want to try this example on your own before you resume the video to see if you can do this without my assistance. So we're looking at 2 equations, 2x plus y equals 5, and y equals 3/2 x minus 2. Our goal is to graph them both and find the point of intersection and then check our answer. If you're interested, pause the video, try it now, and then resume. All right, so if I was doing this problem, the first thing I would do is put them both into y equals mx plus b form. So for number 1, I would subtract 2x from both sides for the top equation, so that I'd have y equals negative 2x plus 5. That way they're both in the same slope-intercept form that we're used to. So I'm going to graph the top equation first. We have a y-intercept of 5 and a slope of negative 2. So we're going to go down 2 over 1 each time. And it's good here to plot a number of points, just because your accuracy with line drawing will improve as you have more points to draw through. And don't forget your arrows on your lines as well, because these aren't line segments, they are actual lines. The second one is a y-intercept of negative 2 and a slope of 3/2. So we're going up 3 over 2 and down 3 over 2. So down 3, left 2, up 3, right 2, up 3, right 2. And again, drawing our line through with arrows. So we can see in this case that it sure looks like our point of intersection is at 2, 1. And so we just want to check that to make sure it's actually correct. And always plug back into the original equations, not the modified equations, in case you made a mistake while you were solving. So the first equation, 2x plus y equals 5, I would have 2 times 2 plus 1 equals 5. 2 times 2 is 4, plus 1 is in fact 5. 5 equals 5, so that's a good sign. The second one, we'd have 1 for y. Y equals 3/2 multiplied by 2, because 2 is x, minus 2. 3 halves times 2 is 3, minus 2 is 1, so we have 1 equals 1. Again, that works, and that tells me that 2 comma 1 really is the solution to this problem. All right, so for the last example today, we're going to look at a word problem. So imagine that you own a roofing company, and you need to buy shingles and roofing paper in order to put a new roof on a home. So you go out and you buy 30 bundles of shingles and 4 rolls of roofing paper for $1,040. And then later, the contractor goes back out and buys 8 bundles of shingles for $256. Our goal is to find out how much the shingles cost and how much the roofing paper costs. And the first thing whenever we do a word problem is we always define our variables first. And I guess for this problem, I'm going to say that R comes before S. So I'm going to use X is going to be our price of roofing paper. And Y is going to be the price of bundles of shingles. And obviously you could define your variables opposite mine. It's just important that you do define them so you know what you're doing. So if X is the price of roofing paper, we know that the contractor bought 30 bundles of shingles and 4 bundles of roofing paper for $1,040. So I could say 4 times the price of roofing paper plus 30 times the price of shingles equals 1,040. That could be our first equation, coming from this sentence right here. And then the second sentence, we also know the contractor bought 8 bundles of shingles for $256. So I could say that 8y equals 256. Now, because these numbers are much larger, you could certainly graph this by hand, but we're actually going to do this one on our calculator so I can show you how that works. But remember that our calculator only accepts equations in the form of y equals. So we need to solve both of these equations for y. The bottom one is pretty easy. We're just going to divide both sides by 8, and we end up with y equals 32. But for the top one, first we're going to subtract 4x from both sides. So we have 30y equals negative 4x plus 1,040. Then we're going to divide everything by 30. So we would have y equals, now negative 4 over 30 is the same thing as negative 2 over 15. So we'd have negative 2x over 15. 1,040 divided by 30 is the same thing as 104 divided by 3. And if you think about it, 104 is not divisible by 3 because its digits don't add up to 3. So we would just have 104 over 3. So we've got our two equations here, right? We have y equals 32 and y equals negative 2x over 15 plus 104 over 3. Our goal is to find out where these intersect so we can get the prices. And we're going to do that together on our calculator. So if you pull up your graphing calculator as well, and hopefully yours will work better than mine is working. So if I pull up my graphing calculator here, we're going to enter both of these equations into y equals. So we've got y equals 32. And then we've also got y equals negative 2x over 15 plus 104 over 3. And then our goal is to graph these. Now if I press graph right now, I'm not going to see anything because my window is way too small for these numbers. If you think about it, if you just look at the numbers, you can see that we're definitely not going to be in a 10 by 10 window. We also know that our prices can't be negative, so I'm going to make my minimums 0, but I'm going to make my maximums a lot bigger, like maybe $50 each just to start with. So I'm going to go from 0 to 50. And if I don't see it, that's okay. We'll just make our window bigger. All right, so we can see one of our lines here, and we can also see the other one coming across as well. So we can kind of eyeball the intersection slightly, but we want to be much more accurate. And your calculator can actually find intersection points for you. And the way you do that is we want to use the calculate feature of our calculator. In other words, we're going to press the blue button and then press the trace button. And that'll get us to calculate. Now we want to find the intersection, and as you might guess, that's number 5, the one called intersect. So you go down to number 5, hit enter, and it's going to ask you 3 questions. The first question it's going to ask you is first curve. It wants to know, in case you're graphing more than 2 curves, it wants to know which 2 you want to find that intersect. Since we're only graphing 2, when it asks you first curve, you can just hit enter. When it asks you second curve, you can just hit enter. And then when it asks you to guess, it's asking you to move the cursor to a place where you think the intersection is. So I might move it just a little bit, I don't know, kind of up here, and then hit enter. And then when you guess, it'll find the exact intersection for you. So in this case, our intersection is 20, 32. So my intersection point would be 20, 32. But if I actually wanted to answer the problem, it says find the price per bundle of shingles. So the price per bundle of shingles would be $32. And the price of roofing paper per roll of roofing paper would be $20, because we want to remember our units when we are doing word problems. So that brings us to the end of this video. When you do your homework, unless it's a word problem, you should not be using your graphing calculator at all. But if you're doing a word problem with large numbers, it's fine with me if you use your graphing calculator to find the intersection. As you might guess, you definitely want to use graph paper for this homework assignment. So give the homework a try and let me know if you have any questions.